Welcome to an example in which we are answering a memory ability question. Here we go. Is memory ability before a meal better than after a meal? 10 people were given memory tests before their meal and then again after their meal. The data is shown below. A higher score indicates a better memory ability. Okay. So basically what they did, this is person number one right here. Person number one got an 87 before on the memory test before the meal, and then he or she retook a different memory test after the meal, also got 87. Person two got a lower score after the meal, 51 before the meal, 46 after. Person three got a 51 before, 49 after. Person four did the same on both. Person five went down a little bit. Person six went up after the meal. Person seven went down. Person eight went way down after the meal on the memory test. Person nine went down a little bit. Person 10 went down a little bit. So it looks like most people went down. You know, when they have a full stomach, there's not as much blood in their brain. It's in their stomach digesting their food. So they're not as sharp. Their memory ability is not quite as good. Although one person went up, most people went down. So anyway, we're testing, is memory ability, what does it say? Before a meal better than after a meal? I mean, it looks like it's a little better, but is this strong evidence or not? We'll see. Okay, so first off, we come in here and we're supposed to figure out what can be concluded. For this study, we should use, now you can see the answer there already. It's a t-test for the difference between two dependent population means. So there's obviously two groups there, right? We have two groups, clearly. We're talking about well, I mean, actually it's the same group. It's 10 people, but those 10 people took a memory test before their meal, got those 10 scores, and those same 10 people took a memory test after their meal and got those scores. So so those are dependent. Dependent. How do we know those are dependent? Well, so we're not going to choose the independent because those are the same exact people, right? Like this 51 and 46, that's the same person. That's what he or she got on the memory test before the meal, and then 46 is what he or she got on the memory test after the meal. That's the same person. So that's dependent, like family members are dependent on one another, they're connected. So when the groups are connected like that, we call that dependent. Now, they could have set this whole test up differently. They could have had 10 people take a memory test before eating a meal, and then a different 10 people, totally different group of 10 people, unrelated to the first group, take a memory test after the meal. That would have been independent, two independent, separate, unrelated groups. They could have done that. But the way they're doing it here is better because it's the same exact people, right? It's a dependent study, meaning why this is better is because, if you just had 10 people take the test before the meal and then a different 10 people take the test after they ate a meal, say the scores were higher before or after or whatever, you would just think, well, it's just a different 10 people. Maybe those 10 people just have better memories or something like that. Maybe it has nothing to do with the meal. Whereas if you have the very same 10 people taking the test twice, once before the meal, once after, if they did better before the meal, then you're like, well, those are the same people. So maybe the meal did make a difference, So it's a better study, and it's called a dependent study because these numbers are dependent on one another, connected, they're related, they're the same person before and after the meal. All right, so this is a dependent study. Let's come on down here. For the HO, we're going to choose mu1. It's not P1, it's average, right? Average score. And mu2. It's right here. So mu1 and mu2. And what always goes in the middle for HO? It's always equal, isn't it? So HO is always equal. And then for H1, we're going to have mu1, mu2. It's going to be greater or less or not equal, like it always is. What does it say up here? Is memory ability before a meal better? Better means greater, higher, right? Greater, better. So is mu1. So this is mu1 is the before. And this is the after the meal, before the meal. So mu1's before the meal. How do you know that's mu1? Well, that's just what they put here first. This is mu1, this is mu2. They just listed it first, right? Before the meal came first, then after. So mu1's before the meal, after is it greater? Is mu1 greater? Is before the meal greater? That's what we're testing. All right. Well, here's the numbers from the test, statistic, and the p-value. Let me show you how you get that. Where we're going to go is we're going to go to calculator number 20, which is dependent, whatever it says, something like two dependent. Wait, let me go there. Two dependent groups on that. Go to the calculator for us. Oops, it's not the right place. So here it is. Okay, so we're going to the calculator. Yeah, it's number 20, two dependent samples. See it down there, number 20, two dependent samples with data. So choose number 20, I already have. When you choose number 20, this will pop up. And I put the data 1, I put that list in there already. Let me go do data list 2. Let me show you how I did that. So for data list 2, so I'm going to grab that data. So it's two, again, this is two dependent samples, calculator number 20. And then you basically just paste the data and then choose the radio button, which is going to be the greater. Choose the radio button greater and then hit calculate. So let me do that. So I come back over here. Let me show you how I'll actually do the pasting here. Oh wait, that's not the right one. There it is. Okay, so watch. I'll actually, if I can do it. There we go. I'm going to copy that. Copy that data and then come back to the calculator. And I will paste it. There we go. And you got to put commas between it. So I'll stick commas between all that. So I'd already pasted the first group, data 1. So now I'm just showing you how I copy and paste data 2. All right. And then choose the right radio button, greater. Ours was greater. See these radio buttons over here? I'm choosing greater and then calculate. And there we got a T and a P. See that T value, P value 0.986, and the P is 0.1748. So let's go back. And there they are, just like calculator totals, 0.986, 0.1749, same thing, close enough. So we've got a P value and a test statistic. So now we're ready to try to wrap up this question. So I'll come over here and I'll write P value and alpha level. The alpha level is right here, 0.01. The P value is right there, 0.1749. So what's the story? Greater. 17 is obviously greater than 0.01. What does that mean? You remember what that means? If P is low, HO must go away, right? So that means if you have P value less than alpha, we don't, then that would mean reject HO, keep H1, strong evidence. But that's not our situation. We instead have p-value greater than alpha. That means fail to reject. Fail to reject HO, keep HO. Weak evidence. That's where we're at. So, right, because if the P is low, the HO must go, where our P is not low. See that? Our P is greater. Our p-value is greater. Our p-value 17 is greater. It's not low, it's greater. So that means you come down here. It's greater, which means fail to reject HO, right? If the p-value is not low, then the HO must not go away. Don't reject HO. Keep HO, weak evidence. Okay. So that down here, we're going to say fail to reject the null. The evidence is weak. Okay, now final conclusion. So our conclusion is that memory ability before a meal is what? Equal, greater, less, not equal to memory ability after the meal. Well, remember how we make that final conclusion. Keep HO, it says it right there. Keep HO. And then you go right on back to HO. What's HO? It's this right here. This is what we're keeping. HO. What does it say? Equal. Equal. So we're concluding that memory ability before a meal is equal to memory ability after meal, right? Even though there was some evidence that memory ability went down, it just wasn't clear enough, right? If you look at this table, they're pretty close. And so that p-value, the calculator told us the p-value is 17. That's p-value is the percent chance of luck. There's a 17% chance, which is pretty high, that any differences you're seeing here between the the before the meal scores and the after the meal scores are just because of luck. Maybe they just, they were just had a easier test. They were accidentally given an easier test after or before or whatever. It's just random luck, or they just guessed better or something like that. There's a 17% chance that any differences we see here are just because of luck. That's a pretty high chance. That's too high. Anything higher than 1% of chance of luck, we were not going to consider strong evidence. So we're like, nah, it's not strong evidence. We think they're basically equal. There's not really a big difference. And so there we go. It all came from calculator number 20. And so that's how we do that.